This is the L298N dual H-bridge motor driver. This is a very versatile module that gives you control of DC motors and stepper motors. With this module, you can control the direction and speed of 2 DC motors up to 2 amps each, or 1 stepper motor. These are very inexpensive modules that cost about $3 a piece, and you can find them on eBay, Amazon, or other online stores. In this video, I'll show you how to drive 2 DC motors to control the direction and speed, and I'll show you how to control a stepper motor as well. This is motor A connector, and this is motor B connector. To control 2 DC motors, you connect one motor to the motor A connector and the other motor to motor B connector. The polarity is not necessarily important. To control a stepper motor, you need to connect one phase to motor A and another phase to motor B connector. You can use a unipolar or bipolar stepper motor. These are the power connections. You have the power supply input, ground, and 5-volt input or output. This means it can either be 5-volt output or 5-volt input, depending on how the module is powered. The power supply input range is about 5 volts to 35 volts DC. If your power supply is 7 to 12 volts DC, leave this jumper in place. This jumper connects the power supply voltage to the onboard 5-volt regulator to power the board. If the power supply voltage is greater than 12 volts, then you should remove the jumper. The voltage regulator can only handle up to 12 volts, from what I understand. If you remove the jumper, you will need to power the board with 5 volts at the 5-volt connector. If the power supply voltage is 7 to 12 volts, then this connection is a 5-volt output instead of an input when the jumper is in place. You can use the 5 volts to power your Arduino, your PIC microcontroller, or other devices, depending on the power consumption. This section is where you control the motors, or stepper motor. All these inputs are controlled by TTL signals. There's specific ranges for TTL voltages, but to make this simple, 0 voltage is low and 5 volts is high. This jumper enables output motor A, and this jumper enables output motor B. If you are controlling 2 DC motors and you want control of the speed of those motors, you need to remove the 2 jumpers and provide a variable PWM signal to these 2 pins. With the jumpers in place, the motors will have full power, or 100% duty cycle. N1 and N2 controls the direction for motor A by applying a high signal, or 5 volts, to N1 or N2. One of these pins will cause the motor to go forward and the other in reverse. The same goes for N3 and N4. These inputs control motor B. Depending on which way you connected the motor, it will determine which input drives forward or reverse. Okay, I connected 2 DC motors to the L298N module. If you notice the white wire that is feeding into the power supply input, that is 5 volts. And since 5 volts cannot turn on the onboard 5-volt regulator, I also need to feed 5 volts into the 5-volt input, which is the yellow wire. The green wire is ground. Also have 5 volts here that I'm going to connect to N1 to N4, and that will control the motors. N1 and N2 will control the left motor, and N3 and N4 will control the right motor. Note that the 5 volts I have here, and the 5 volts on the white wire and the 5 volts on the yellow wire, they all share the same ground. Two DC motors, and I'm using a microcontroller, which is the one right there. Like I mentioned before, to control a stepper motor, you need to connect one phase to motor A connector and the other phase to motor B connector. Note that there is easier and more efficient driver boards out there for controlling stepper motors. For driving a stepper motor, make sure Enable A and Enable B jumpers are in place. I created this push button circuit to help me figure out the sequence of pulses that I need to feed into the N1 to N4. This orange wire is connected to positive 5 volts. And when I press one of these buttons, it'll feed 5 volts into the corresponding input. Once you figure out the sequence to move the stepper motor in one direction, you just need to reverse the sequence to move it in the other direction. Okay, I have my push button circuit here to help me figure out the sequence for driving this stepper motor. First of all, I have two of the phases connected to the driver board. One phase is connected to motor A connector, and another phase of the stepper motor is connected to motor B connector. I also have 12 volts coming into the power supply input, as well as ground. The 5 volts is actually an output now, so I can take 5 volts out of that connector if I wanted to. So after playing around with the push buttons, I figured out that one of the sequences is 1, 3, 2, 4. 1, 3, 2, 4. 1, 3, 2, 4. 1, 3, 2, 4. And that actually moves the stepper motor clockwise. So I can just add pulses to the N1 to N4 inputs to drive the stepper motor forward. If I wanted to drive the stepper motor counterclockwise, I would reverse that sequence, and that would be 4, 2, 3, 1. 4, 2, 3, 1. 4, 2, 3, 1. 4, 2, 3, 1. 4, 2, 3, 1. And that's the sequence for driving the stepper motor in a counterclockwise direction. I am going to drive a stepper motor. It's a NEMA 17. And here's the PIC microcontroller. You can forget everything else around it. Okay, I connected a different stepper motor to the motor driver. This one happens to be a PM4222-09. So one thing I had to do was modify my code so it can do one revolution, clockwise and counterclockwise. I'm using the same microcontroller. So if you need to control a couple of DC motors or even a stepper motor, the L298N dual H-bridge motor driver is an option. Thanks for watching my video. Please like and subscribe to see my future videos. Have a great day.